Free body diagram is a very helpful tool to describe the dynamics of an object. It is a drawing that contains all the external forces acting on the object. Remember that internal forces cancel out and do not participate in the motion of the object. Therefore, we do not include them in the free body diagram. Once we have the drawing of the free body diagram, we can apply Newton's second law. Remember, it says that the net force acting on an object is equal to the mass times its acceleration. So, knowing all the external forces acting on the object allows us to calculate the acceleration of the object. If we know the initial conditions, its position and velocity at an instant of time, we can predict the future motion of the object. Keep in mind that the acceleration can also be zero. In this case, the net force is zero, the sum of all the external forces is zero. Be careful that if the net force is zero, that does not mean that the object is not moving. It means that it is not accelerating. For example, consider a box sliding down an incline with friction. Here we have as external forces the weight of the box pointing down. We also have the normal force between the box and the floor. This is always perpendicular to the floor. We also have the force of friction, which is pointing against the motion. In this case, we would have these three forces. To work with this, it is better if we project in the x and y axis.
Now if you see my baby is oh so fine.
We will then apply Newton's second law to both axes.
She's long and lean and never mean. She tastes like cherry wine and she's
In the next video, I will solve a simple example where I need to draw the free body diagram of an object under external forces with acceleration.